So we're going to use the unit circle to see what it looks like graphically, and I've always been back and forth of whether I should put degrees and radians in the same spot like this. Because when you do use the TI-83s to graph, you have to be very careful what mode you're in and what your window is when you graph. Because over here, for example, yeah, here's 360 degrees and there's 2 pi. We know that to be the same. Does your calculator necessarily know that? No, because your calculator looks at 2 pi as 6.28. That's how your calculator sees 2 pi, because it thinks of it as 3.14 times 2. And so really, we're saying that 360 and 6.28 are the same thing. So do you see how that could confuse your calculator? Right? We know them to be the same. It does not view them the same because it really looks at them as just 2 numbers. Okay? And so what we're going to do is we're going to go along and we're going to get some of these values. So right here is 0 for, say, an x value, correct? Or 0 is the degree that I'm talking about. Because on the x-axis, do you agree it's degrees and radians, or what the angle is? That's really what our x-axis is here. And so let's go and take a look at 0 degrees, and we're going to look for sine at 0 degrees. So which value should I be looking at? Well, here's 0 degrees. So which one of those two right there is the sine value? The y is, so 0 degrees, the sine value is 0. So you go back to your graph at 0 degrees, the sine value is 0. So in other words, if I put 0 degrees in right there and took sine of it, I would get 0. So that's where that point goes. So I'm saying that 2 tick marks is 180. So how much is 1 tick mark? 90, or pi over 2 if you like to look at it that way. So let's go ahead and say, well, instead of putting 0 in there, we're going to put pi over 2 in there, or 90 degrees. And so you go back over here and you say, okay, well, here's 90 degrees, and I'm trying to find sine of 90 degrees. And so which of the values is that? It's 1. It's the y value. So I'm saying for 90 degrees, which is right here, the value that I get is 1. Do you agree with that? So now go to 180 degrees or pi. At 180 degrees, we're over here, again, known as pi. What's the sine value over there? Back to 0. So at 180 degrees, it would be 0 if I took sine of that. Okay. Well, what's that next tick mark then? 270, yeah. We go over to 270. Whoop, got to scroll a little bit here if I can. Is -1, yeah, if you look down there. So at 270, where should I put my dot then? At -1, and get as close as you can. I'm kind of on the side here. And how about 360 degrees? Well, shouldn't that be the same as 0? Isn't that the same thing on the unit circle? And so at 0, it was 0. So at 360, it better be 0. Now, the key is what happens in between all of these things. And so if you wanted to, we could obviously go back here and kind of put 45 degrees in, right? If you go back to the unit circle, 45 degrees gives you a y value of square root of 2 over 2, agreed? Which is 0.707, which is, somewhere in the middle, right? Is there anything weird that happens, say, from 0 to 90 with sine? Is there anything weird that happens? No? And from 0 to 90, what can you tell me about sine? It's always positive, correct? So does it make sense that it would do something like that? How about from 90 to 180? From 90 to 180, does anything strange happen with sine? It always has a value, right, as we go along, and it's always. So does that make sense that it's up here like this? Yeah. How about from 180 to 270? Maybe let's take a look at that one. Sine is the y value, right? And sine is negative. So does it make sense that it's negative? Yes. Okay, so it goes down like this. Well, what do you suppose it does to finish off? Disconnects. Well, how about the negative degrees? Do you think, what's going to happen? Is it going to do something strange? Well, maybe it does, right? So let's go do, what's this one right here? That'd be negative 90 degrees, right? What happens how do you do negatives again? Yeah, you go around the circle the other way, right? So negative 90 degrees is really saying the same thing as 270, right? And what is the sine value there? It's -1, right? Okay, so go back there. So it's -1. Would -180 be the same as +180? Shouldn't it end up the same? Yeah, it's the same spot, so it goes there. -270 is similar to saying what? Negative 270 and what are the same thing that we've already done? 90, right? And what was it at 90? It was at positive 1. And negative 360 better be the same as 0. And so right there. And so, well, do a little better than I did there. Does it make sense that this graph is incredibly symmetric? You know why? Because it's based off of a circle. Okay, so is it going to be symmetric? You bet it is. Okay. So that's how you do sine. Because is there any really places with sine that cause any trouble? No. Are there any places with cosine that cause any trouble? No. But I am going to do another one with you because there are some places on this other one that can cause some trouble. And the one I want to do is secant. Secant is known as 1 over, which one?
Sine.
1 over cosine. So there are actually some values that I'm very interested in right away. Because we now have a fraction, agreed? And 1 over something is a big no-no. 1 over a radical is a big no-no, not the one I was looking for. The one thing that's undefined in math, 0. 1 over 0 is a big problem. Does cosine ever equal 0? Look at your unit circle. Does cosine ever equal 0? Yes, it does. That's a problem. So we need to find out how to solve that problem. So let's go first find out where is cosine. 0. So we'll go to our unit circle. We'll clean things up a little bit here. Cosine's which value again then? X. So we're finding where is x 0. Is x 0 over here at 0 degrees? No. Well, where is x 0 then? Well, 90 and 270. So also, if I went this way, it'd be negative 90 and negative 270. Agreed? Those are places that cosine is 0. So can I graph anything at those places if it's 1 over 0? No, you can't. And here's what we're going to graph. So where were those places again? We'll make a note. 90 degrees and 270 is where we had a problem, correct? And I would always look for places that cause a problem. Were we going to have over 0 ever when we did sine before? No. But now we are. So at 90 degrees, which is right here, I hope you agree, we are not allowed to graph anything. So we're going to make, it's really an imaginary line is what it is. It's kind of just understood to be there. We've done them before. Asymptotes. Very good. So 90 and 270. Negative 90. Where's negative 90? Yeah, first tick mark to the left. And I'm going to go right through my 1 over cosine. Now the nice thing is you don't necessarily have to remember how we did them earlier this year with asymptotes. We're going to find out what happens in between the asymptotes. And that will actually be something that you have most definitely seen before. And we got time left. Well, last time we didn't worry about asymptotes because it was sine. We didn't have to worry about it and there was no problems. Here it was over cosine, so we knew there was going to be some places that it was divided by 0, which is bad. And that's where we put the asymptotes. So let's go ahead, let's go to 0 degrees, and we're going to substitute it into cosine and see what happens. Because what we're going to do is we're going to put it right there and find out what happens. All right? So we're going to go to 0 degrees. Here we are over here at 0 degrees. What is cosine? It is 1. So what we're going to do is we're going to do 1 over 1, which is 1. So at 0 degrees, it's 1 over 1, which is 1. So 0 degrees and graph 1. Well, is it just a dot? That'd be great if it was, we'd be done. But it's not. So let's go ahead and find that tick mark. What would that tick mark be? How many degrees? 45. Okay. 45 degrees. So let's go back 45 degrees right here, right? 45 degrees. What is cosine there? Square root of 2 over 2, right? But we have to do 1 over that. So we have to do 1 over square root of 2 over 2. So either at this point you could go to your calculator if you had one, or what you have to do is take this square root of 2 over 2 and flip it. Yeah. So it's 2 over the square root of 2, which is unacceptable. No. Nice try. But if I were you, I would just find the decimal. No. 1.414, and here's why. Multiplied by the conjugate. 2 square root of 2 over 2. It's just the square root of 2 is all it is, which is 1.4. So give or take right about there. You just take this and flip it, which is 2 over the square root of 2, because it's times 1, so it doesn't matter. Then you take it times the conjugate. So it's 2 square root of 2 over the square root of 4, which is 2. The 2's cancel, it's square root of 2, which is 1.414. Well, how about negative 45? Isn't it the exact same thing? Yeah. So it's 1.4 again? See, that's a nice thing. You do it once and you kind of got it figured out. All right. So that's over here. Any ideas what that may look like? A parabola or a smiley face. Very good. Told you it would become something you have seen before. We're going to make it. What do you mean on the bottom? Who said that? Where? Where's it going to be on the bottom? Right there. That is so descriptive. And pointing from 15 feet away. Well, let's go to pi and find out what happens then if we don't know. We got to find cosine at pi. What do we got? Cosine at pi is, but it's, remember, it's 1 over negative 1. 1 over negative 1 is negative 1. If I type this in, isn't that going to be negative square root of 2 over 2 for that value right here? So it's 1 over that, so it's going to be negative 1.4. This one's also going to be negative 1.4. So Hannah is correct. Yes. What is cosine at 180? Cosine, not sine. And so it's 1 over negative 1, which is negative 1. No, that's all right. So what's going to happen here? Do you agree that this value right here at 2 pi should be the same that it was at 0? So it's going to be back up here. So in other words, all it's going to do is that. Any guesses for between? So once again, so descriptive. Negative 270 to negative 90 is going to be below and above. Obviously, if my graph kept going, these parabolas would finish, but I stopped them. So my suggestion to you is if there is ever anything on the bottom, find out where is that going to be 0 so you can find out where the asymptotes are first. Obviously with cosine, just cosine, you don't have to do that. But when you do cosecant, you should probably find those places.